In this lecture video, we're going to move on to alcohols. And quite honestly, after this lecture module is over, you probably will want to stay on alcohols, but that's the way organic material is going to be. So an alcohol is a random group that contains carbon, and then off of that group we have an OH. So that OH is what we refer to as the alcohol group. So we have to kind of learn how to name these structures as well. I mean, we did it with the alkyl halides. We did it with the ethers that we just talked about in the last 2 or so videos. And now we need to focus on the alcohols. Just like before, alcohols have a common nomenclature system, and they also have an IUPAC nomenclature system. So I'm going to focus on the common names first, and then I'll go and we'll talk about the IUPAC names. So the way that we common name alcohols is we are going to look for our longest carbon chain, and we're going to name that as an alkyl group. So for instance, methyl, ethyl, propyl, butyl, isopropyl, and so forth. So very similar to what we've done in the past. There is really no major change that happens here. We just name it with a YL ending, and then at the end of this name, we add the word alcohol onto the structure's name. All right, and that's it. That's all that we've got to do. Pretty simple, right? All right, so let me give you some examples, and we'll do commons first, and then we'll go back and do some IUPACs. All right, so let's take a look at CH3OH. Okay, so the longest carbon chain here is a 1 carbon, so we're going to call this a methyl group, and then this OH is going to be represented with the word alcohol. There you go, people, methyl alcohol. That's all that we have to do. Methyl alcohol was the old alcohol that moonshiners would get into their moonshine if they did not distill it over the proper way and make them go blind when they drank their moonshine. So don't let that happen to you, okay? Methyl alcohol is very bad, but it's also a very common solvent that we use in an organic lab. So don't let organic laboratory make you go blind either. All right, CH3CH2OH. Well, the common nomenclature system here, I name the longest carbon chain, which is 2, and I name it as a ethyl, and then I add the word alcohol onto that name. So ethyl alcohol, this is the alcohol that your ABC store sells, all right? So CH3, CH2, CH2OH, well, 3 carbon chain here. That 3 carbon chain is going to be called a propyl, and then I add the word alcohol onto the end. I can do a CH3CH with a CH3 that points down like this and an OH kind of in the middle. There's your traditional L shape, that 3 carbon system that has a kink there with the attachment in the middle carbon. That L shape is your isopropyl. And then we add the word alcohol onto the end. Folks, I hope that sounds very familiar, isopropyl alcohol, because that's your rubbing alcohol that you would find at places like Walmart and Target and your pharmacies that are around town. So there you go. All right, next one, let's do a CH3, CH, CH3, CH2, and then OH. Okay, so I still see the L kink that's right there. So this is still an iso group, and if I count the total number of carbons, it's an isobutyl group, and then that OH we are going to refer to as an alcohol. All right, so there you go. I mean, that's how we commonly name alcohols in organic chemistry. That's all there is to it. However, we are limited, just like before. Not all of these groups can be referred to in a common way. So the larger that these groups become, the bigger that the alcohol becomes, the more chances of it not having a common name exist. All right. So we have to have an IUPAC name in place. And we would prefer you to use the IUPAC whenever you can. That's something that, again, never goes away. Ethers were somewhat of an exception because we kind of had better sense in the common nomenclature field with ethers, but alcohols really go back and divert back to like the alkyl halides and the rest of them as well. We really would like for you to use IUPAC whenever we can. All right, so let's take a look at the IUPAC rules. And we'll just go back and we'll take a look at the very first one that we did, and that was methyl alcohol. So how do we name this using the IUPAC system or the systematic system? Okay, so what we do here with this is that we go through, sorry for that brain fart, my writing pad actually just disconnected from the computer. Who knows why? I've got a ghost. All right, so CH3OH, we want to IUPAC it. This would be called a methyl alcohol, but here's the rules of IUPAC. You find the longest carbon chain and you name it. So this is going to be called a methane normally, right? Methane, longest carbon chain, just like before, just like always when it concerns these endings. And then what we do is that we go through and we erase this E at the very end. So if that was ethane, erase the E. If that was propane, you erase the E, and so forth. And then we modify the ending and we add the word OL, or the letters OL. The OL, if you look at the word alcohol, it ends in OL, so that is why we use OL as the ending here. So CH3OH is also called methanol, and methanol is the IUPAC name for that alcohol, and that is what we prefer you to use in a laboratory. It is truly the IUPAC nomenclature that's the preferred system here. All right, CH3CH2OH. Well, we did this one as well. This normally longest carbon chain would be ethane, and then we erase that E, and we add the letters OL there on the end, and we call this ethanol. So once again, the drinking alcohol, ethanol, is also a very good solvent for us in a laboratory environment. In addition to this, this is a 2-carbon system. I would number this carbon as carbon number 1, and this one, of course, carbon number 2. You can put a 1 in front of here. All right, that's perfectly okay, but it's not needed, because if there's no number, it's understood to be on the first position anyway. That's just the rules of IUPAC, all right? So you don't have to write it. You can leave it off. And then in addition, some people don't like that format, and they want to break this up, and they want to put the number closest to the OL ending to let you know for sure that that OH group is attached to the first carbon, and they will call this ethan-1-ol. Well, that is another IUPAC name that this thing can go by, and that's perfectly acceptable as well. However, I know very few people that feel comfortable in doing this type of thing, and if you do not feel comfortable doing it, then don't do it. But that is an option that's out there. So 1-ethanol, ethanol, or ethan-1-ol, all of those are acceptable names for that particular type of structure, okay? Next, we'll do CH3, CH2, CH2OH. That's what we did with the common name. Longest carbon chain here is propane. And what I would do is I would drop the E, and I would change that to an OL. So this is called propanol, all right? Again, this is carbon number 1. That's where the OH is attached to. I would number starting there, and that could be a 1-propanol if that's what you wanted, but you don't have to. It's understood to be that way. All right. Here, CH3, CH, CH3, and then OH. We called this isopropyl alcohol for the common name, but now we need to IUPAC it. So how do we do that? You find the longest carbon chain. So the longest carbon chain here is still a 3. There it is. So this is a propane. You still drop the E and you add the OL to it. So this is still a propanol. But now we have to give this OH group a real true number because it's not on the end. All right. And it doesn't really matter how you number it. You can start from the left and go around and down, or start down and go up and over. Doesn't really matter. You'll get the same number no matter what. So we call this a 2-propanol. So that 2 lets me know that the OH group is attached on the second carbon of the chain. All right. Again, if you don't like that and you feel that this is ambiguous in a way, then this is propan 2-ol. And that is also an acceptable name. Look, I'm going crazy today. My tablet has unplugged. My microphone has fell down. This is not the day for me. So, maybe I need to call it quits at this point in time and then come back and try this all over again on another day, right? No, that's not what I'm going to do. I'm going to keep doing example problems. All right, so let me clear this screen out and we'll go through and we'll do some more examples. So in this example, let's do CH3, CH with an OH that points down, CH2, and CH3. All right, so we've got to go through and we've got to IUPAC this name. And when we IUPAC it, we've got the longest carbon chain, and that longest carbon chain is 4. There we go. So this is a butane. Then we drop the E and we add all because that represents an alcohol. And then we have to tell you where, position-wise, that OH group is going to be attached to. So carbon 1, carbon 2, carbon 3, carbon 4. That gives me the lower number. And on carbon number 2, I have the OH group. So 2-butanol or butan 2-all. Either one, perfectly okay with me. All right, next, CH3, CH2, CH2, CH. And then from that carbon, let's go down and write like a CH2 and a CH3 here. And then a CH2 and then an OH. Okay, so we've got to find the longest carbon chain, right? So the longest carbon chain, 1, 2, 3, 4, 5. I can do better. 1, 2, 3, 4, 5, 6. It looks like that is the longest carbon chain. So I start circling this, and then I'm going to scream, and I'm going to say, no, 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 that's not the longest carbon chain. What? Why isn't it? Isn't that what we've did this whole time? Well, yeah, it kind of is. But the problem here, see, is that the OH group is a group that we have to include in the name. So the longest carbon chain has to include what we're naming it as. And if we're going to name this as an alcohol, then the longest carbon chain has to include that carbon in the longest carbon chain. And if we go across and then down, we miss that carbon. We are not including that carbon that has the OH group, and that is a have to. So by default, we have to include the carbon that the OH is going to be attached to at this point. So from this position, I've got 1 carbon. The next one over is 2. If I go down, that's 3 and 4. If I go across, that's 1, 2, 3, 4, 5. So this is truly my longest carbon chain. That's the only way that this thing is going to work. So that way, this can be carbon number 1, this can be carbon 2, carbon 3, carbon 4, carbon 5. So this is a pentane, because there's 5 carbons in total. I drop the E, and I add the word OL for pentanol. Now you can kind of, again, understand why the longest carbon chain has to include the OH group. We cannot bypass it. We're naming it as an alcohol, therefore it has to be included in the longest carbon chain. So pentanol is going to be the name for the root, and then here on carbon number 1, I have the term pentanol. That's where my OH group is going to be. At carbon number 2, I then have this 2-carbon piece, and that 2-carbon piece is called ethyl. So 2-ethyl, 1-pentanol, or I can shorthand this a little bit. 2-ethyl pentanol is another way that we can write that word. Or 2-ethyl pentan 1-all is also acceptable as well. So either one of these are perfectly okay. I don't really care which one you use. Blackboard, if you're doing those automated assignments, it might actually count one of your answers wrong accidentally, but hopefully I will catch it and I'll correct it if it does. All right. Next, let's do CH3, CH2, CH2, CH2O, CH2, 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 OH. Oh, this is a good one, right? Here we have an OH group, and we have a ROR group. So I have an ether, and I also have an alcohol. So we need the longest carbon chain here, right? So you're going to look at this and go 1, 2, 3, 4. And then on this side, 1, 2, 3. So 4 is the longest carbon chain. This is the same reasoning as up above. We are getting ready to name this as an alcohol. Alcohols take priority over ethers, which take priority over alkyl halides. So the alcohols, we have to name it as an alcohol, which means that this longest carbon chain has to include that OH group. So we have to, by force, use this as our longest carbon chain. And we're naming it as an alcohol. We're going to number closest to that side because of that. And then here's carbon 2 and there's carbon 3. So the name of this is going to be propane. Drop the E and add OL. So propanol. And it's a 1-propanol because my OH group is on the first carbon. Now on the third carbon, I do have another group. And we now know how to name this substituent, don't we? We know now how to name that grouping system. The way that we name this, we've got 4 carbons in total. So this would be a butyl, but I dropped the YL and I changed this to oxy because of that oxygen that's included. So this is a 3-butoxy 1-propanol. And that is why we name it the way that we do. All right? So again, you have to actively think. You have to go through, take a look at these structures, remember how we're naming these structures, and make sure that your longest carbon chain really does include the functional group that you want to name it as. If you do not, then we have a problem. We have an issue, and that's not an acceptable IUPAC name for that structure. Let's do a couple of more of those examples. We'll do OH, and let me rewrite this just a different way because that's not really how it's ordered. So let's do OH this way. All right. So OH, CH2, CH2, Br. And we have to IUPAC this. All right. So the way that we IUPAC it, OH takes preference over the Br. Okay, that's the order working up process that we've done so far. So OH, we're going to name it as an alcohol. So therefore, that is carbon number 1, and this is carbon number 2. So this 2-carbon chain is ethane, typically. We drop the E, we add OL. So this is an ethanol, and at carbon number 1, that's where the OH group is going to be located. On carbon number 2, that is where we get our bromo group. So 2-bromo, 1-ethanol is going to be the name of the structure. All right, let's do another one, Cl, and then we have a CH2, a CH2, a CH, a CH3, and then down here below we have an OH group. Longest carbon chain, this is going to be 4 all the way across. So this is going to be a butane. We drop the E and we add the OL to that for butanol. And we have to figure out what number it is because this is the preference here. This is the priority. We're naming it as an alcohol. So I don't want a number to the left. If I do, that gives my OH group a higher number, and that's something that I don't want. So because we're giving it priority, because I'm naming it as an alcohol, I want to give the OH group the lowest number possible, and that is a 2. So this is a 2-butanol. And then on carbon number 4, I have a chloro group. So 4-chloro, 2-butanol is going to be the name of that structure. Next, CH3, carbon. Let's put a CH3 that points up and a CH3 that points down. We have a CH2, a CH, a CH3, and then on this carbon, we'll have an OH group. So when we name the structure, again, we have to include the longest carbon chain that has the OH. And if we look at this structure, we can go pretty much straight across. I mean, that's going to be our longest carbon chain right there. 1, 2, 3, 4, 5. So this is going to be a pentane. I drop the E and I add OL for pentanol. And I'm going to number it closest to the end of the OH group if that's how I'm going to name this. So carbon 1, carbon 2, carbon 3, carbon 4, and carbon 5. So on carbon number 2, that is where my OH group is going to be. So 2-pentanol. All right, but on carbon number 4, I have more substituent groups, and I see a methyl group to the top and a methyl group to the bottom. So this is a dimethyl group, and it's going to be written as a 4,4 dimethyl 2-pentanol. And again, the reason I do that is because I know there's 2 groups. Dimethyl represents that, but each group requires a number in IUPAC. So there are 2 groups on the 4th carbon of the main chain. Therefore, each one does need that number, and I need to write down the 4 twice. There's no shortcut with the numbering as far as IUPAC goes in the nomenclature system. All right. Again, let's go through and let's kind of take a look at some more examples while we're on a roll. CH3, CH, and then here, let's draw a chlorine that goes down. CH, CH2, CH3, and then here, let's draw an OH that comes down. All right, so we've got to name this. Well, just like before, what I'll do is that I'll circle the longest carbon chain, and that's here at the very top. If I count across 1, 2, 3, 4, 5, this is going to be a pentane. I drop the E, I add the word or letters OL for pentanol. All right, well, where do I go? 1, 2, 3 over from the left, or 1, 2, 3 over from the right. No matter which way I number, the OH group is going to get the lowest number here at either from the left or from the right. So it's going to be a 3 no matter what. However, we have this chlorine group that's also there, and I want to give that now preference as well. If we have a tie on left or right-handed numbering, then let's just go ahead and number from the left. That way, chloro gets a 2 and not a 4. All right, so this is going to be a 2 chloro and then a 3 pentanol for the IUPAC name. 2 chloro, 3 pentanol. Something else that I would like to start throwing into these examples, notice that this OH group is attached to a carbon. This carbon's attached to 2 others. So this is a secondary carbon, and that means that this is a secondary alcohol. All right, so that's something I don't want you to forget, and that is the way that we make those determinations. All right, let's do another example. CH3, CH2, CH2, CH with an OH that points down, CH2, CH, CH3 that points down, and CH3. Okay, we're getting bigger and bigger and bigger as far as this structure goes. I'm going to name this as an alcohol. All right, so I know that. I need to include the longest carbon chain that includes the alcohol group, which is the OH group. So when I do that, here all the way across, there we go. And 1, 2, 3, 4, 5, 6, 7. All right, so that means that this is a heptane. I drop the E, I add OL for alcohol, and now I need to figure out what number. So if I start from the left, that's a 1, 2, 3, 4, and if I start from the right-hand side, that's a 1, 2, 3, 4. So alcohol is tied. So I need to look at other groups and give those lower numbers now when I begin to number the system, because it doesn't matter in terms of OH group. So I'm going to start numbering from the right-hand side here. That way this methyl group gets a lower number, and no matter which way I did it, OH was going to get a 4 no matter what. So this is a 4-heptanol, and this is a 2-methyl that goes along with it. So 2-methyl, 4-heptanol. The OH group is attached to a carbon. That carbon's attached to 2 others. So therefore, this is a secondary carbon, and that means that this is a secondary alcohol. Next, let's do a ring structure. Here's a ring structure with a CH3 group and an OH that comes off of it. We have to name this thing. All right, so the longest carbon chain is a cyclohexane, right? But I drop the E and I add OL. So cyclohexanol. Well, if I need to give OH group the lowest number because I've named it that way, I need to give that carbon position number 1. So this is a 1 cyclohexanol. And that means that I need to go counterclockwise and give that methyl group position 3. So 3 methyl, 1 cyclohexanol, Or if you wanted to, you could leave that one off. I mean, that's a personal preference thing on your side. 3-methyl cyclohexanol would, again, be an acceptable answer for that particular alcohol. All right. If I look at this OH group, this is attached to a carbon that has 2 other carbons attached. So therefore, this is a secondary alcohol because it's on a secondary carbon. I'm going to keep doing some more examples here. CH3, CH with a BR that points down, CH2, CH2, or sorry, CH, CH2, CH3 on top, and then CH2, CH with an OH that points down, and then a CH3. So I need to go through and I need to name this based on the rules that we've used always so far up to this point. I'm going to name it as an alcohol. Therefore, I want my longest carbon chain to include the OH group. All right, so if I look at my longest carbon chain, 1, 2, 3, 4. If I go up, that's 5, 6. All right, if I go all the way across, that's 1, 2, 3, 4, 5, 6, 7. So there's my longest carbon chain. So it's right here. I'm going to circle that for you. So this is a heptane. Drop the E, add OL for alcohol, and a number closest to this side. So this is a 2-heptanol. All right, well, if that's carbon 2, this is 3, there's carbon 4, there's carbon 5, and there's carbon 6, and there's carbon 7. So up here at the top, this CH2CH3, that is an ethyl group. And then here we have a bromo group. Well, B comes before E. So that's the way that I would want to start this. So 6 bromo, 4 ethyl, 2 heptanol is going to be the name of that alcohol. All right. Here we'll do another ring. We'll have a CH2CH3 that's here. And then we'll have an OH group that's there. And here we'll have a CH3 that's here. All right, so now I need to name this. Oh, by the way, this OH group up here at the top, that is on a carbon that's attached to 2 others. So this is a secondary carbon, and that's a secondary alcohol. All right, so let's go back and name this structure. This is a ring structure, so I know that this is a cyclohexane. I drop the E, I add on the OL. So because of that, I'm going to name this as an alcohol, and therefore that is going to, by default, get the number 1 position. Now I need to figure out which way around the ring do I need to go with this. I need to try to give everything the lowest number possible. If I go clockwise, this is spot 2, this is spot 3, spot 4, spot 5, and spot 6. I've got a 3 and a 6 that I have to deal with. If I go counterclockwise, well, this is spot 1, this would be spot 2, that's 3, that's 4, and this would be spot 5. So this is actually going to give me lower group numbers if I do this. So I have to go counterclockwise with my numbering here. So spot 1 will be my OH group. Spot 2 will be my ethyl group. And then 3, 4, and spot 5 will be my methyl group. I need to put these in alphabetical order. E comes before M. So this is going to be a 2 ethyl, and then a 5 methyl, and a 1 cyclohexanol. But again, I can leave that 1 off. It's understood to be there. All right, so there's the name of that beefy OH group that we have brought into the picture. All right, so we'll do one more, and then that's where I'll stop the video. We'll do this cyclopentane ring, and we have a CH3 group here, and a CH3 group there, and an OH group that's going to be here. All right, so the longest carbon chain is going to be cyclopentane, but I drop the E and I add OL because this is going to be named as an alcohol. So by default, this is carbon number 1. And I can put a 1 there if I want to. I don't have to. It's understood to be there if I don't. So there's my 1. And then I need to figure out how to number this. So if I go clockwise, this is spot 2, this is spot 3, and this is spot 4. And if I go counterclockwise, this is spot 1, this is spot 2, this is 3, and this is 4. It gives you the same numbers no matter what. So whichever way that you go here, on far as numbering based on these locations and these groups, you're going to get the same answer. So at spot 3 and at spot 4, I have 2 methyl groups. So 3,4-dimethyl, 1-cyclopentanol. Again, this is a secondary carbon because it's attached to 2 others. Therefore, this is a secondary alcohol that we have. All right, so that's where this video is going to stop. We're not done with the alcohol examples yet, though. We're going to come back, and in the next video, we're going to focus on another set of alcohol examples. We're going to go through, and we are going to name them, and we're going to identify them as primary, secondary, or tertiary, and so forth. So we're not yet done with alcohols. There's more examples to be done, but this is giving you a good assortment of things to go by and some practice again on how to name the alcohols, both the common way and the IUPAC way. Notice what I did though. I introduced common and I told you simple alcohols can be named a common way, and then we quickly went over to IUPAC and we focused on IUPAC from that point on. Almost all of our examples were focused on the IUPAC names. Every single one of them here in the very end was nothing but IUPAC. There was just a handful of common names in the very beginning, and that was it. So in the next video, we'll go back, we'll take a look at alcohols, we'll name them yet again, and we'll assign their primary, secondary, or tertiary notations.